Hi class, we are Group 12 and for our presentation we conduct data analytics on Amazon and Netflix video streaming service content. Video streaming services have been popular for years, but due to the pandemic, there has been a spike in the demand for these services. Additionally, new streaming services were created and existing ones were further developed. The problem that we want to address is that the new customers searching for video streaming services may feel overwhelmed when they try to select one. Even if they decide to select one of the more popular services, which are Netflix and Amazon, they still will know which one has the best content to suit their taste. Our role throughout the project was to implement a series of data analytic techniques in order to highlight the key differences between the two more popular video streaming services. We began by selecting a dataset on Kaggle, which had a lot of information on different video streaming platforms. This dataset includes a series of variables that were used to data analytics such as year, age, rating, and more. Before we completely clean up the data, we found that IMDb had the misinformation between the two rating systems. Our role was blank in the column were removed and the descriptive statistics were performed on the IMDb variable. Finally, the rest of the dataset was cleaned up, removed any row with the missing information.
Next, descriptive statistics were performed on the IMDb scores of the new sample data and was compared to the old data. This was to ensure that the new sample data set accurately resembled the original data in quality within an acceptable margin. In order to clean up the rest of the sample data, descriptive statistics were applied to the rest of our variables. Next, the z-scores were calculated for select variables. Outliers were identified but not removed. Instead, we verified or updated the outlier information. At this point, new variables were generated in order to assist us with our data analytics. A majority were binary so they can be used in hierarchical, clustering, association rules, and more. With the new binary data, association rules were generated to determine which pairs of genres were strongly associated with one another. We found that drama is typically associated with crime, comedy, romance, and thrillers, and that romance drama and crime drama have the strongest associations. Hierarchical clustering was performed twice, using the availability on each platform, high ratings, and the three most popular genres. Our analysis revealed that the titles with both comedy and drama genres score high on Rotten Tomatoes. Titles with a high rating from both IMDb and Rotten Tomatoes are more associated with comedy and drama genres. Amazon Prime is mostly associated with comedy and drama genres.
Next, a correlation table was generated between the variables year, age, number of genres, IMDb, and Rotten Tomatoes. The only moderately strong correlation was between IMDb and Rotten Tomatoes. Even though they are both rating systems, they are calculated differently. IMDb uses a weighted system which allows all users to contribute to the ratings, while Rotten Tomatoes only permits top critics to contribute to the ratings on their website. Since Rotten Tomatoes prevents any reviews to be posted prior to a movie's release date, and IMDb allows early screeners to post their reviews, we believe that IMDb scores may influence Rotten Tomatoes ratings to a certain extent. The linear regression model showed that roughly 42% of the variability in values of our sample could be explained by this model. This means that IMDb scores have some impact on Rotten Tomatoes ratings, which implies that the platform with the larger percent distribution of high IMDb scores should also have a larger percent distribution of Rotten Tomatoes ratings. This idea is confirmed in the following slide. This bar graph shows the percentage of content with high ratings between Netflix and Amazon Prime. From the linear regression model, we assume that the platform with a larger distribution of high IMDb scores will also have a larger distribution of high Rotten Tomatoes ratings, which is verified in the bar graph.
Another key difference between Netflix and Amazon is that Amazon actually offers significantly more content than Netflix. Specifically, our data suggests a 1.7 to 1 ratio. In this visual, we observe that 74.47% of Netflix's content primarily consists of the titles released in 2010 and later, compared to Amazon Prime's 49.56%. This allows us to determine that Netflix focuses more on ensuring that their content consists of the latest titles compared to Amazon.
Lastly, the k-nearest neighbors classification method was used to determine if a combination of all our numerical variables could be used to predict if content is available or unavailable on Netflix and Amazon Prime. Our analysis allowed us to conclude that although content quantity was a key component in these models, the area under the curve values suggest that both provide acceptable distinctions in predicting whether content is available or unavailable on each streaming platform. This supports the idea that distinctions between the two services truly exist. Selecting the right video streaming service doesn't have to feel like a daunting task. The statistical differences in the content offered between Netflix and Amazon Prime could assist consumers in selecting the video streaming service that best suits their needs. Through the use of data analytics, key distinctions were identified in content type, quantity, and quality. Hopefully, consumers find value in this information and use it to assist them in selecting the ideal video streaming service for them.